terms of randomness, I found this simple walk experiment that is done by our software. It's more critical to be operated in such manner. This stochastic process, it's very interesting topic that can be widely used when we have an application that requires some randomness, and the output of it can be somewhat different than others. For example, in the flow of currents in electricity and to escalator, and sometimes in the stock market. However, now, first of all, to perform the simple random walk, we knew that the random walk, when a person don't know which direction it's going, there are some interesting commands. First of all, we have to set the seed, and this command is to unify and standardize the answer so that eventually we can get all the same results. Then we need to translate these steps into shocks and assign it as a simple random variable. It means that we pick random values from -1 to 1, mean moving forward or backward inside the concatenation C, and the size of it is, we have 500 steps, and replace it's 2. That means we can go forward or backward many times. We know that the values that we obtain from the simple walk, it's not periodic, it's not a period, it's just discrete values. So we assign it as a function walk discrete and CumSum. That means that we need the summation of these steps. Okay, and then eventually we can use the plot function to see this graph. So now first of all, let's run one by one and see how we are doing so far. We have unexpected simple. Okay, this is our answer in the console screen. As you can notice, we have moving backward 1 step, forward 2 step, backward, forward, and here's our result. Then to plot it, to make a plot, we use this command plot ts. Okay, as we having some problems in this command, I think that unexpected simple. Let me do it for you. Okay, here's the problem. Okay, this is our simple discrete walk graph. As you can see, here is the step is written in X direction and the Y direction is position as we need it. And then we need to replicate. It's the command replicate, it just means to repeat this for 1000 times. Okay, and as you can note, it's appearing some good results here. And this is the 1000 time results. We have the Y 499 because simply if we have, this is the steps in the X direction and the replication 499, we need the 499 because it will cover all the points of the graph. So that's why we choose the 499. It's just simply more wider, and it will pick all the necessary points. So there are two methods to perform the sample walk test. First method is line by line, and it simply is, and this method is more accurate and more precise. Interesting to see that each command is follow each other. It's like a chain, and we simply, in this case, we did it in a simple way that it did not contain any mean or standard deviation. But in this time, if we need to put the mean value of 0 and standard deviation, so we have to perform the GeoShock, or it refers to Gaussian model. So let's use the GeoShock. Then this is our random normal distribution, which has 500 steps and 0 mean and 101 standard SD. And this is the result of the 20 steps, which has specific mean and standard deviation. And as you can see, when we define or assign the GWalk with the CumSum, you can see we have the final value of 17.29, because it's just a summation of all the previous value, unlike the previous command that it's just present the results without some summation, without addition. This is why we need the CumSum to provide the last answer. And this is the plot, the Gaussian walk. And here, if we actually need to replicate for 1000 times. Dimension, we set the dimension of Gaussian replication. It gives 500 and 1000. It's just simply stating the horizontal and the vertical direction values. It just provides the dimension of the whole scenario. So here is for the whole 1000 steps, our result. And if we need just a histogram of it, this is the histogram. Okay, we need to adjust the line density and make it more clearer, like to have more appearance of the line. We set it like the density of it that has color blue and width f2. For example, if we change this to 5, let's see how it reacts. See how the width is changing. This is called the line by line method. Otherwise, we have this method. It's just open braces and put everything inside. First of all, you must be careful. Maybe this function, the random walk Gaussian, is not available on your PC. You have to see or install it from the library, and the code for the RW Gaussian's DRC, you just search it in the Google bar and it will just give you what's the code for this function and install it. So we actually did the same procedure. We only make it differently, but eventually we will have the same result. We set the random walk Gaussian, then the function 500 steps with the sigma or standard deviation 1 and the mean is 0, as we did here, but this is in a different shape. 500 steps, 0 mean, 1 SD. Also, we need to specify the cam sum. Okay. And we have to again type the Gaussian random walk, so that after that we put just the head this command, we have this result, and to plot it, and dimension, we set the color as red, 499 position. I think they all have the same, like almost the same results. We now will move to Brother Anwar to continue the second part and explain more in details and in depth about these commands. Thank you.
So in this video we will be solving the random walk problem. Okay, simple random walks. Okay, the problem says that a random walk is a very basic stochastic process. Okay, stochastic process is any process which have certain varying probability. Okay, it has some probability actually. Okay, and we do not know 100% like in which direction it will go, so that is called stochastic process. Okay, in which the probability is involved. Okay, it is a time series where the current value is equal to the post value plus a current shock. Okay, the equation given is y of t is equal to y of t minus 1 plus a of t. Okay, this is the current value yt, current value at time t. This is the previous value at time t minus 1. Okay, and this is the shock at time t. Okay, and it is given that y naught is equal to 0. It means the person starts walk at 0, at some center line, 0 line. Okay, so this is one dimensional random walk. Okay, think of it like this. Okay, this is a straight line. This is center of the line, which is 0. Okay, imagine some boy or a man is sitting over here, okay, at 0. Now he stands up and starts walking. Okay, so at each walk he has a bite. Okay, now here is an equal probability that he will either walk and take a step in this direction or take a step in this backward direction. Okay, this is +1, this is -1. Okay, now if he take the steps in this direction, then AT is equal to 1, and we know that Y0 is equal to 0, so Y1 is equal to Y0 plus A1. Now A1, for example, he starts in forward direction, so A1 is equal to 1, and we know that Y0 is equal to 0, which is already given to us, so Y1 is equal to 0 plus 1 is equal to 1. Okay, for example, this is 1 feet, for example, each step is 1 feet. Okay, now Y2, okay, so Y2 will be equal to Y1 plus A2. Okay, now there is an equal probability that second time he will either move from this direction, from this point, this is A1, okay, in this direction, or he can move another step forward. Okay, so this is the simple random walk. Okay, so this AT, this is either -1 or +1. Okay, this is the simple discrete random walk. Discrete because the step is equal to either +1 or -1. Okay, so that is why it is discrete, it is not continuous. Okay, we have a solid figure for that, so that is why it is discrete. Okay, so we will first do the first option of it, which says on based of the simple discrete random walk, okay, write the function. Write function in R for this, for discrete simple random walk. Okay, I explained this discrete simple random walk previously. Okay, now we will tackle this problem chronologically. Okay, it means we will understand how to tackle this problem from defining the problem to programming and interpreting the results. Okay, we will follow each step. The very first step was to understand the mathematics of it. Okay, and we have done it. Okay, so if you have any problem in the exam or in practical life, okay, first you have to understand the mathematical model of it if it is given to you. Okay, or understand the basics of that problem, the background of that problem. Okay, now that we have understood this simple discrete random walk, okay, mathematically and physically, like from this line, okay, now we will move towards the breaking this problem into an algorithm form. Okay, now let's break this mathematical model into algorithm, and then we will identify the R functions, okay, that can help us solve this problem. Okay, then we will code one walk and then scale it to many walks like 500 or 600 or 1000 steps, and then we will summarize and interpret the results. Okay, so here we will move forward to step 2, which is breaking the model into algorithmic parts. Okay, now according to the problem, okay, we have defined as, the person starts at 0, okay, he take a step forward or backward, which is defined by +1 and -1 discrete steps, okay, which is called as shock at, okay, shock at time t. Okay, so the first part of this algorithm is to start at 0. Okay, this is the first part of the algorithm. We always have to start at 0, that is y0 is equal to 0. Secondly, we have to generate random shocks, okay, because it has equal probability that he can either move forward or backward. In the second step, it is also of equal probability that he can either move forward another step or go backward at 0 position, okay, if the first step was forward. Okay, so we will have to generate the random shocks or steps. Okay, and the third part in this algorithm is to take the sum of these steps or shocks. So we will have to find the cumulative shocks or cumulative sum. Okay, this is the algorithm. Start at 0, generate random steps or shocks, and take the sum of it. Okay, that is the algorithm for us. Now we will identify the, this is the step 3. Okay, step 3 is to identify the R functions that can help model this problem. Okay, so this is the third step. This step is also very crucial because you need to know about the functions of it that can actually help you model this problem in R. Okay, so for that we need to understand the problem, okay, and the things that are required from us in the problem, okay, that will identify the R functions. Okay, so the very first thing is the sample function. Okay, then I will later on explain why we use sample. Okay, the second thing is because it can either move forward or backward, okay, at random, so random normal is another function that we can use over here. Then the cumulative sum, because we are taking the summation of these steps, so cumulative sum is the another function. Fourth one is, as we have to replicate this problem for 1000 steps or 500 steps or 500 shocks, so replicate is another one that we can use. As we need to make the histogram, okay, so hist is another function, and to plot that we can use the plot. Okay, so these are some of the functions that are, in my opinion, useful to us, to define this problem in R and solve it. Okay, so let's start coding this problem in the R module. Okay, let us code one walk, then scale it to the 500 or 1000 steps, and then summarize or interpret the results. Okay, so let's start the problem. Okay, so let's program it. Okay, so to program the simple random walk, okay, the very first thing is that I have to set the seed. Okay, this is used like if I am using the same seed and you are also using the same seed, the result that we get will be exactly the same. So it makes the problem reproducible, okay, and we get the same values. Okay, so most often the teacher will say you that set the seed this much, okay, so that you and the teacher both get the same result and he can check your work properly, okay, without any confusion. So we will first set the seed, okay, then the very second thing that we need is to define this shock 80. Okay, so we will have a variable shock, okay, and we will give it a value of random, okay, between -1 and 1. Okay, the overall size n, it should be like 500 steps, okay, and the replacement should be true, okay, because we can randomly pick more than 2 times, a step. Like a person can move consecutively 2 steps backward or 3 steps backward, okay, so it is totally random. Okay, so the replacement is true. Okay, let me explain also this code that I wrote over here. Okay, seed, I told you that it is for reproducibility. Okay, shock, okay, this is 80, okay, and we assign it a value sample. Okay, by sample we pick the random values between -1 and 1. He can either move forward or backward one at a time. Okay, but we say that replace is true. It means that he can pick the second shock also a forward or a backward. Okay, so he can pick -1 or +1 multiple times. It's not like he will say he will move forward one time and then he will have to pick the downward or the backward step the next time, and then forward and this backward and so on. No, he can pick either forward or backward multiple times, -1 or +1 multiple times. Okay, so that is why we say replacement is true. Okay, and the size is equal to 500, n is equal to 500. It means that we have 500 steps. Okay, now to convert this shock into the walk, okay, so what we do, we introduce a random variable walk and assign it a value of the cumulative sum of these shocks. Okay, so it will convert these particular small discrete shocks into a walk. Okay, now we can plot this random walk, okay, using the plot.ts function. Okay, by ts we mean the time series. Okay, because he walks at certain time, it is discrete. Okay, so it will plot the time series of this walk from 1 to 100 steps or 500 steps. Okay, so we can use the plot.ts to plot this time series function. Okay, so now let's do it in the random or environment. Okay, let me open the RStudio. Let me delete these things. Okay, so the very first thing is to set the seed. Okay, set seed and bracket open. Okay, so what it will give me is, for example, we want to have the seed 1 2 3, for example. Okay, and press enter. Okay, so now if the teacher also says you or tells you that set the seed like for example 10,000, so your answer and the teacher's answer, it should be the same. Okay, so that is why seed is important. Okay, it makes the problem reproducible at some other computer, or it will give you the same results. Simple as that. Okay, so we set the seed 1 2 3. That is why I am telling you about the seed, is that in exam most probably the teacher will let you set the seed at his option. Okay, so that his answer and your answer are the same. Okay, and he can check you thoroughly. Okay, so he will give you a seed for that. Okay, so after setting the seed for 1 2 3, okay, the very first thing is that we need to, because we know that yt is equal to yt minus 1 plus at, so randomly at time t1, okay, at time t is equal to 1, y1 is equal to 0 plus the shock. So for that we need to set the shock. Okay, so let me write it as shocks as the variable, and we assign the value to shocks as we will use the sample function. And why we will use the sample function? Because it will pick the value between -1 and +1. Okay, it will pick randomly the value between -1 and +1. Okay, and we say that size is equal to 500 steps. Okay, and replacement is true because the person can go backward or forward 2 position or 3 position consecutively. Okay, so this line will actually define the random shocks as a random value between -1 or +1, and the total size is 500 and the replacement is true. It means that the person can pick -1 or 1s repetitively. Okay, he can move forward 2 times in the forward direction or 2 times in the backward direction consecutively. Okay, so the replacement is true. Now when I press enter, it will get me to the next line. Now that we have defined the shocks, now in order to translate this shock into a random walk, we need to define a variable walk, and we know that walk is the summation of these shocks. Okay, so we can do the same here. We can have the cumulative sum of these shocks as defined as the walk. Okay, so for example, I say walk and I say discrete walk. Okay, walk discrete. Okay, and I assign it a value as the cumulative sum, okay, of x. Now here the x is the shocks, so I will say shocks and press enter. Now what it will do, it will convert these shocks into the discrete walk. Okay, so now if you want to see that if what were the the first 20 or 10 or 15 or 35 steps, okay, so we can use the head function. Okay, so it says head x and then dot dot dot. It means that first you need to define the variable. So our variable is the walk discrete. Okay, sorry, shocks, comma, and I say, for example, first 20 shocks. I need to when I run it, it gives us the first 20 shocks like this. The first time he moves forward, backward, then backward, then forward, then backward, then forward, backward, 3 times forward, backward, backward, and then backward. So these are the first 20 shocks or steps that he has or she has taken from the 0 position. Okay, now it means that our program, our code is working. Okay, now that we have checked the first 20 shocks, now we would like to actually plot this discrete walk. So as this is a discrete walk, okay, and we will plot it using the plot dot time series ts. Okay, we will use this function. Okay, now it gives us the syntax of it. Okay, sorry, let me do it again so you can see the time, the syntax. Okay, so it says x y plot type, xy label, xy line. There are so many things on here, but the only things that we need are that we are going to, this x means the discrete walk. Okay, so we will put this variable x as the walk disk that we have mentioned over here. Okay, walk DISC. Okay, now that we have mentioned it and put comma, okay, one variable is defined. It means that we want to plot this discrete walk of 500 steps. Okay, now we can also return the value of this walk disk. Okay, let me also do that in the next one. Okay, so after that we need to define that what in this plot the x axis represents and what the y axis represents. Okay, that is the most important thing in after the variable definition. Okay, so variable defined, now we have to define what the x axis represent and what the y axis represent in this plot, and what is this actually mainly called. Okay, so main is the simple discrete walk, okay, and comma, and y lab is equal to position. Okay, by y lab means the label for y. Okay, y label, and x lab is equal to the step. Okay, so now this plot is done. So let me run it. String constant in plot, notice word is simple. Okay, there is something wrong with my syntax here. Okay, let me figure it out. Okay, one thing is that I forgot to make this main is equal to this. I forgot to put is equal to sign over here. So now let's run it again if it works. Okay, now it has given me this discrete walk. Okay, now this y-axis, okay, this shows the position, this x-axis shows the step. Okay, this is the step number. Okay, and this shows the position. Okay, so we have plotted successfully the 500 steps. Okay, these are 500 steps. You see the x-axis is up to 500. Okay, so that is how the plot and these kind of things work in the R program. Okay, now we will move forward towards the more complexity of it, which says that I need to replicate these 500 steps 1000 times. It means that I have to replicate this project 1000 times. Okay, so let's now use the replicate function, okay, to replicate this one experiment 1000 times. Okay, okay, so this, how do you expect the output to be returned? Okay, we can use the return option as well as the head option. Okay, so how was the output returned? So we use the head option. Okay, and we return the first 20 discrete steps. Okay, we can also use the return option, and we can use the return walk disk to actually return all the 500 values. Okay, then plot all the simulated random ones in one plot. We also did that using the plot.ts function. Okay, now the first three things are done. Now I want to make a histogram of the 499th value of your random walk. Okay, so make a histogram of 499th value of your random walk. Okay, so let's now do it this one. Okay, so first we need to replicate this simple discrete walk. Okay, so for that we need to use the replicate function. Okay, now we need to replicate it 1000 times, so n over here is 1000. Okay, 1000 comma, then it says which one to replicate. Okay, so we want to replicate this walk disk. Okay, so let's see if it replicates it. let's run it. It is giving me error, so there must be something wrong with it. Okay, now it has replicated the walk disk, discrete walk 1000 times. Okay, this is the result of all the walks. Okay, so now this one works. Okay, so I need to do replicate 1000 times, and what I need to replicate? The discrete walk, which is represented by the variable walk disk. Okay, so when we enter it, it replicates it. Now in order to have the 499th step of this replicate, okay, I need to place or assign this replicate to some variable. Okay, so for that I need a variable. So for example, here I will say discrete walk, and I assign it this replication. Okay, now this replication will be assigned to this new variable, which is discrete walk. Okay, now from this discrete walk I can actually have the 499th shock, okay, or 499th value. So if you remember, when this is a kind of matrix, okay, now we have x-axis and y-axis. The x-axis is equal to 500 units, okay, which is each discrete walk, which has 500 steps. Okay, and the y-axis are from 1 to 1000, which are the replications. Okay, and we are interested in the 499th value of the each walk. It means that we are interested in the what we say, the 499th y value, not the x value but the 499th y value. Okay, so for that we need to have another variable like y499. Okay, and I assign it a value. Okay, and that is the value which I need from this. So when I want to call this value, I will use the square bracket. Okay, so I want it from discrete walk. Okay, and I want, so I will start the square bracket and I will say 499 comma, and I will leave the second value blank. Okay, why I need 499? Okay, because if I show you on page, okay, this is our, for example, this is our x and y graph. Okay, these are from 1 to 500. Okay, these are the individual walks. Okay, these are the replications which goes from 0 to 1000. Okay, now I need the 499th value from each walk. Okay, so these are each walk, and this is the 499th iteration. So if I say 499 comma 0 or null, it will show me all these values from these 500 walks. Okay, so if I run it, let's see what it shows. Object discrete walk not found. Okay, I have a spelling mistake over here. Here I haven't. Now it will be okay. Okay, I need to print a return. Why 499? Okay, not showing me this thing. Maybe just 499 will work because we have a single variable of 499 over here, so maybe it works. It's not working, actually working. Okay, the return was not working, but if I type y499, because we have kept this 499th value into y499 variable, so when I press or type y499, it will show you all these values. So from every iteration, the 499th value is present here. Okay, I hope you find it useful. Okay, I will jump to the next part of it, which is the Gaussian one. Okay, with the standard deviation of 1 and the mean with 0. Okay, this was -1 and +1 in between. Okay, randomly, but that is pure Gaussian. Okay, it is a normal probability plot. Okay, so now we will do the second part of it. Okay, the problem that professor gave, the random walk problem. Okay, so the second part says that it is not just a random walk, but it is a pure Gaussian walk, like the mean of the shocks is 0 and the standard deviation or sigma is equal to 1. It means that the walk follows the normal distribution with the mean of 0 and standard deviation of 1. Okay, so the very first thing that we will know now here earlier the step was either +1 or -1. +1 meaning forward one step. Okay, for example, that one step was like 1 feet. Okay, and -1, so negative feet backwards. Okay, but in this case of the Gaussian, okay, the person, okay, suppose this is the length. Okay, the person is sitting here is at 0 position, at center position 0. Okay, now at random, according to the normal distribution with 0 mean and standard deviation of 1, okay, he can move 0.3 forward or 0.5 another step forward, or then in the third step -0.7 backward. Okay, -0.2 another backward, and so on. Okay, or even a big leap like +1.8 forward as the, for example, this is first step, second step, third step, fourth step, and this is the fifth step. Okay, and then the sixth step, the -1.2, and so on at random. Okay, so this is how the Gaussian, well, the step size is not fixed here, while in the first one the step size was fixed either +1 or -1. Okay, so this is the Gaussian random walk. Okay, now we will try to code this one. okay, in the RStudio. Okay, we can code it in two ways. Okay, the very first method is to code it line by line. Okay, and the second method is to code it as a function. Okay, remember that we used a function command, okay, and then we started this curly bracket, okay, and then we have like body of the code in 2-3 lines, and then we close this curly bracket. Okay, so the second way is like this, and the first way is to code it line by line. Okay, first define the shock, then assemble the shocks in walk by sum, cumulative sum, and then return the value of the walk, or just define the walk. Okay, so we do it on both of the methods. Okay, so let's now make the code using the first method. Okay, so the first method is that the first thing that we need to introduce is to introduce a variable, okay, for shock, and shock have mean, zero mean, and 1 is standard deviation. Okay, so for that, for example, I say Gaussian shock, okay, GU shock, okay, and I assign it the value, okay, random normal, okay, with the n, okay, which is the number of steps, and here we have 500 steps. Okay, mean, which is 0, and standard deviation is equal to 1. Okay, then we say the Gaussian GU walk, okay, and we assign it the value to cumulative sum of these GU shocks. Okay, and then we can return the value of this GU shock, or just type GU shock and control plus enter will give us this whole in numeric form. Okay, or we can use the value of the function of head and bracket to have all these 500 steps, or 10 steps, or 20 steps at start. Okay, so let's first do it this way, and then we will code it as a function also. Okay, the first problem can also be done as a function, okay, but I just did it line by line. Okay, I have sent you the file. Okay, so now let's code it. Okay, now we are in the RStudio environment. So the very first thing, as in general the teacher asks for, or we do, is to have the reproducibility of the same problem. Okay, so for that we set the seed. Okay, so this seed will be given to you by your teacher, okay, so that your answer and your teacher's answer remain the same, and he can check you thoroughly. Okay, so first setting the seed. Now the very first thing that we need to do is to introduce the shocks, or the bytes, or what we can say, the steps. Okay, now the every step follows the Gaussian one. Okay, so I will introduce GU, it means GU shocks, okay, Gaussian shocks. I will assign it the value of random normal distribution, because it is Gaussian. Gaussian means that it follows the normal distribution perfectly. Okay, so when I open the bracket, it gives me the syntax of it. So it says n is 500. Okay, 500 steps. Okay, mean is 0 and standard deviation is 1 over here. Okay, we can also write mean is equal to 0 and SG is equal to 1. Okay, but just writing the number separated by comma, the function understand that it has given me n, mean and standard deviation. Okay, so you can do it both ways. Now checking if this is working. Okay, so now I will use the head function to have this these like GU shocks, comma, for example first 20 shocks. Okay, first 20 steps of the walk. Okay, when I run it, let's see what it gives us. Okay, so it is giving me the perfect first 20 steps of the object or the person who is doing this walk. Okay, we see that we have minus 1.26 highest at negative. We must also have like 1.78. Okay, so it means that we are doing fine. Okay, we can also have like this 500, and then we can have mean is equal to 0 and SD is equal to 1. Okay, that is also good. Okay, but we will do just like we did it. Okay, just giving the number, the R normal function understands that the first number is n, the second number is mean, and the third number is the standard deviation. Okay, so don't need to worry about like you have to give the mean according to the syntax. Okay, now we have, for example, I want to have $500 steps. Okay, now when I run it, okay, it will give me all the 500 steps over here. Okay, so we can literally visualize all the steps of this random walk. Okay, now the next thing that we need to do is we need to sum all these steps. Okay, so that we know where actually the person is going. So it will give us a graph. Okay, we can plot that graph according to the timeline. Okay, the time series. So for that we need to have the cumulative sum, and that cumulative sum is assigned to a variable called GU walk. Okay, because the sum of these shocks will give us a walk. Okay, so I introduce GU walk. By GU walk I mean you can literally give it any name. Okay, but I am giving it a name of GU walk because it is Gaussian walk. So GU for Gaussian and walk for walk. Okay, and I press Alt plus negative sign. Okay, subtraction. So it will assign this variable the value that I will write here, and the value is the cumulative sum sum. Okay, now it will give me x. Now what are the things that we need to sum? We need to sum the GU shocks. Okay, so I will, because the variable is GU shock, so I will also write GU shock over here, not shocks. If I say shocks, so this will give me an error over here. Okay, because GU shocks is not defined. It will say the object GU shocks is not defined. We have defined the GU shock, so it will be the cumulative sum of the GU shock. Okay, now if I return the value of the GU walk, let's see what it gives us. Okay, GU walk is not found. Okay, So if I just write GU walk, let's see what does. Okay, the final point is 17.29. okay, it means that in feet the person have moved into the positive direction of 17.29 feet in 500 steps. Okay, sometime he may have moved negative, sometime he may have moved in positive direction, but the overall walk is 17.29 feet in positive direction. Okay, now we can actually plot this time series. Okay, so when I open the brackets, it says what do you want to plot. So I want to plot the GU walk. Okay, and it says that what are the XY labels. Okay, what you want to have the X level written, XY level, the Y level written over here. What names are you giving it? Okay, so I will have GU walk. Okay, I want to plot the GU walk. Okay, now I want to have that the main is equal to give you the name of the plot. Okay, so the name of the plot is Gaussian walk, for example. Okay, and I press comma, and after comma I write the Y lab and X lab. Okay, so Y lab, the label Y is equal to, and I will open these these signs. Okay, now the Y actually, it will show the position. Okay, and the X label, okay, it will show the step. Okay, this is all I need. Okay, so when I execute this, when I run it, let's see what. Okay, unexpected string in plot. Okay, I guess I have to run all these collectively. No, there is some error. The error is in the last one. Okay, okay, so what the mistake I made is I didn't have like equal to sign over here. Okay, so I put equal to sign after the X label. Okay, I have equal to sign against all these, but I didn't have the equal to sign in the X lab. So when I now it gives me a perfect Gaussian walk over here. Okay, and the final position, it will be 17.29. okay, this is the final position of the person. Okay, you see that sometime he is going in plus, sometime he is going in negative, and so on. Okay, so he climbs up to 17.29 feet. So now I have to simulate this walk of 500, okay, 1000 times. Okay, and then let's see what happens. Okay, so now we need to replicate or simulate this 500 steps project 1000 times. Okay, so for that, the function that we will be using is the replicate function. Okay, so to view the replication, we need a variable to assign that replication to. Okay, we need to assign that replication to certain variable and then return the value of that certain variable. Okay, so for that, for example, I say that these 1000 replications are GU rep. Okay, I assign GU rep as the variable to this replication. Okay, and I press alt negative to assign the value. Now I will use the replicate. Okay, so it says n. Okay, let me do it again so that we can see the syntax. Okay, it says n, experiment, simplify, and array. Okay, so n means how many times you are going to replicate that. So we want 1000 times replication of what? Of this GU work. Okay, so I would say GU work, okay, comma, okay. If you want to add the standard deviation and mean, you can add it, but we have already added to the GU work, so that doesn't matter. Okay, now it will replicate this experiment 1000 times. Okay, and that will be assigned to variable GU rep, the Gaussian replication. Okay, so now when I press enter, now I can have the value for these replications. Okay, any value that you want to pick. Okay, so let me put this replication in simple form on a paper. Okay, okay, so now we have x and y. So this x is from step 1 to 500. This is a single layer. Okay, single layer of experiment, and y, it shows the replication up to 1000 times. Okay, so we can actually return any value among these replications. So for example, I want to see the dimensions of these replications. So what I will say dimension, and it says x, so that x is the GU rep. Okay, and when I run it, so it should give me, okay, that want me to run the previous code also, so that he can learn about the GU rep. Okay, so it says 500 and 1000. It means that it has 500 of the single layer and 1000 of those stacked in. So it will be 500 into 1000 total number of elements in this matrix. These are the dimensions of it. Okay, 500 as x and 1000 y's. Okay, and x represents the number of steps and 1000 y represents the number of replications. Okay, so the total number of elements are 500 multiplied by 1000. Okay, so 500,000 are the total number of elements in this matrix. Okay, we can get any value from that using the square bracket. Okay, now it has replicated the experiment 1000 times. Okay, now we can pick any value. So the question says pick the 499th value. Okay, so for that we must first identify the 499th value as variable, and then we can view it. Okay, so for example, I say y 499, okay, and assign it to the variable that we need. Okay, now we want to see the 499th element of the whole replication. So the replication is GU rep. Okay, so we want the 499th value of this GU rep. Okay, so and to have some value in a certain matrix or an array or data, we use the square bracket. Okay, so I will say GU rep, okay, then I will start the square bracket. Okay, so in the square bracket we need the this one value 499 in the x. Okay, why we need in the x? Because we have from 1 to 500 here, so 499 lies over here. Okay, so 499 is among all these 1000 replications. Okay, so it should give me 1000 values in total, one for each replication. Okay, 499th value of each replication. Okay, so that is the x value. This is the x value 499. I hope you understood my what I am implying here. Okay, here we have the number of steps. Okay, these are from 1 to 500 steps. Okay, we need the 499th. Okay, we can pick it from 1 and we can pick it from the 1000 replications that are stacked above each other. If you want to have 1000 replications, okay, the 499th value for each one, okay, so we will have 1000 total values. Okay, the length of these values will be 1000 because we have 1000 replications, and in each replication we need the 499th value or 499th step value. Okay, so this will give me the value. Now I have assigned this value to the variable y499. So if I press y499, okay, and I run it, so it should give me all the 499th value from 1 to 1000 replication. This is the 499th value for 1000 replication. This is for the 999th one, 998 one, 997 one, and so on. Okay, from 1 to, this is the first replication, this is the first replication, this is the second replication, this is the 10th, and so on up to 1000 replications. So it will give me the value for each replication, and that value is the 499 step. So at 499 step we have an average of like 16 feet. The person goes 16 feet on the 499 step. We see that everyone has 16 feet in the 16 feet is common, 16.74307 and so on. Okay, all of them have the same value. So that is how we can have certain value from an array or data. Okay, now we have to make the histogram of this 499th position. Okay, so for that we will use this function. Okay, so it says x, so x here is y499 comma, now the main of this histogram over here, there's like the main over here is Gaussian work, so here we will have the main is histogram. For example, we want to have this histogram as main label like this. Okay, now it has histogram has x also, so x label, it should be something like step or something, or final position. But here we should write equal to. Okay, and here we have the probability also. And we want to have the probability true. Okay, when I press enter, now I want to have the lines in the graphics. Okay, so the lines in this histogram, okay, the density, okay, y of 499, okay, and it should have some color and width. Okay, so color is equal to, for example, I want to have blue. Okay, and the width of the lines, okay, it should be like 2 mm, for example. Okay, so when I run it, it should give me an histogram. Okay, so this is the histogram that we get. Okay, this is the blue lines. Okay, the mean is at 16 point something. Okay, and so this is the histogram of it. Okay, that is how we find the histogram. Okay, so now we have done it line by line. Okay, this is line by line. We have not embodied it into a function. Now in the second attempt, we are going to embody it into a function n. Okay, and write all these lines into a single body and then close the braces. Okay, so that all the body is embedded, and just we need to have like the final line executed, and it will execute the whole body. Okay, now we have to select all these and run it. But in that way, if we run only the function, it will do all the things. Okay, so that is how you do it single line by line in the Gaussian one. Okay, the random walk is already done, so now I will do the Gaussian using the second method. Okay, I am sending you this file. Okay, so please practice it with me. Okay, if you keep practicing it with me, okay, you will be able to ask questions on time, and we can have a healthier conversation over some point, and you can we can both actually learn and deliver. Okay, thank you. Okay, so now we will do it the second method, which is using the function and the braces. Okay, so what do we do in this method is that first we define function n and then open this function. Okay, now in the next lines, what we do is we write the body of it and then close the function. Okay, so once we are done with it, if we execute this function, so it execute all these lines collectively. Okay, we don't have to select all these and run it. Okay, so for that we need to wrap it into a single function. Okay, so now let's do it that way. So the very first thing is to set the seed. Okay, so when I set the seed, after that I need to define the function. So for that I need to put the function into some random variable. Okay, so the variable is, for example, random walk Gaussian. Okay, this is the function that I select. So I put as I assign the value of this function where n is 500 and sigma is equal to 1. Okay, I assign this value of this function to this variable rw Gaussian. Okay, now I need to define the shock. Okay, and to shock I assign value just like we did previously, r random normal with n. I already defined n is equal to 500, so I just write n over here. Okay, mean is equal to 0. Okay, if I don't write mean over here, just write 0 and that's it. And I write sigma over here. Okay, our sigma is equal to 0. Sigma is equal to 1, or I just write sigma because I already have defined sigma previously in the function. N and sigma are defined. Okay, now I need to translate this shock into walk. Okay, so walk is another variable added, and this is the cumulative sum of these shocks. So okay, and then I can have the head, okay, of walk, and I can have like all 500 or 10 or 20, whatever you want. Okay, you can put n over here. Okay, so it will return the value of this walk. It will show the value like minus 0.3, 0.2, plus 1.9, and so on up till how many want to define over there. Okay, then I will translate this one 500 steps into using the replicate function into the replication 1000 replication, and then we can find the 499th value and plot them, and then obviously we can find the 499th value in each replication. Okay, we can have a set of it. Okay, so now let's do it that way in the R module. Okay, so we are back into the R module. Okay, so the very first thing is to set the seed. Okay, now as it is case sensitive, so it is giving me a proper suggestion. Okay, so I will use this one. Okay, for example, I am using the seed 1 2 3. Okay, you know that why it is used. Okay, now by now you should have known that. Okay, so we will set the seed. After that we will define another variable. Okay, put or assign the value to it a function. Okay, now we want to have this value as a function of two things. Okay, first one is that n is equal to 500. Okay, this is the first variable. The second thing is that sigma is equal to 1. Okay, so this is the function now defined. And we open the braces. Okay, now the brace is open. Now it wants me to write the body of the code. Okay, and then the parenthesis is closed. Okay, so for the body the very first thing that I need to define is to define the shock or shocks, whatever. Okay, you can use shock or shocks, depends on you. Okay, so shock, and the value is the random normal. Okay, so our norm is the function that we go for. Okay, it says define n. Okay, n is already defined, so I will just put n over here. Okay, now it also tells me that mean, so mean is equal to 0 comma, and I say sigma because sigma is already defined. So I don't define the value, just define sigma because sigma value is already defined. Okay, and press enter. Now it should do the job. Okay, now to define, for example, I say g walk. Okay, g walk is the next Gaussian walk. Okay, this is the next walk, next variable that we have. So it is the cumulative sum of all these shocks. Okay, so I will use this function. Okay, and here the x should be the shock. Okay, it is the summation of all these shock. Okay, but I will write shock only. Why shock? Because we have defined only shock over here. If I have defined, it is case sensitive also. It is the the spelling should be exactly correct, because if I write shocks over here and I have defined shock only here, okay, so it will let me the object dash or this thing is not found. Okay, because I have not defined it earlier. Okay, so you need to write the exact thing that is defined earlier. Okay, now it should do me the work. Okay, now I want to have the head function. Okay, and in the head I need to write what I want to, what function or what variable that I'm looking for. Okay, and how many parts. Like for example, I want to have like the first 50 steps of the g walk. Okay, so I need to define the variable and then the number of steps that I want to know about. Now if I run it, okay, it is not showing me. Code is correct, code is correct, but it is not giving me the okay, I must be wrong in this thing. Okay, if I press enter over here and now I have closed the body over there, and there here I will just use the head. Okay, the object gwalk is not found because sorry, if I run it, I don't know what the problem is. I did all the things correct. Let me figure it out what the problem is actually. Now that we have used the braces, let's use the return function. Okay, and we want to return the g walk over here. Okay, I seriously, it is very case sensitive, so you have to, I just had this W in small, but I over here I have W in the capital, so that was the problem. Now I realized, okay, that why it is saying that G walks. You see, here it is small, but if you see here, it is in the capitals. That was the problem. For example, if I run it, I run only this. Okay, I have to run it all. Still the code is correct, but it is not giving me returning the value actually. So let's do it another way. Keep the braces end here and then do this. Again GWalk is not found. What's the problem? Okay, let's use the return function. Okay, spelling mistake. You need to be very, accurate with the spellings and all, okay? Okay, it again says GWalk is not found. I don't know what the problem is. Let me figure this problem out, okay? Okay, so the problem is that the return and this will not work here, okay? And the reason is that we need to include this function somehow, okay? So because the value is stored in the RW Gaussian, okay, so we have to define another variable and put this RW Gaussian in action, okay? So let's say that we have Gaussian random walk, okay, and we assign it the value of this RW Gaussian. Okay, so RW Gaussian, okay, and N is equal to 500 and sigma is equal to 1. Okay, so what we did was, when we first defined the function into this variable, okay, now we put this variable in action over here, okay, using another variable. We did it as a Gauss random walk, okay, and we assign it the value of this RW Gaussian, which has n is equal to 500 and sigma is equal to 1. Okay, now if I say that head and I say Gauss random walk, this one, I copy this, okay, to have no problem with the spell, and okay, and I say 500, okay, so now it should return all the values. Okay, it's not found because we need to select all this and run. Okay, finally now it have returned all the 500 values. Okay, now it is 17.29, exactly like the same. And why it is same? Because we have set the seed as 1 2 3. Okay, that is why seed is important. Okay, so it will give you the exact same random values every time. Okay, so that is how we can use this function and this is another way, okay. But writing, line by line is also a very good method, okay. You don't need to have, to be, kind of doing it is making it more complex a bit, okay, because you have to first define the function, and then the function variable you have to pick again, so this is becoming a bit hard. It's in a loop, kind of loop, okay. So now that we have the values, all the values, we can have replicate it, we can have a plot of it, we can have, like, for example, I want to plot this, okay, and I want to plot this x. So for me, the x is the Gaussian random walk, okay, and here the probability is true, okay, and main is equal to, for example, I want to have, want to name it Gaussian plot, okay, and the y label is equal to, I want to name it the y label as the position, okay. This y shows the position of the person or the object, okay, and x label, okay, it is equal to the, the step, okay. Now if I run this, so it should give me this plot, which is exactly as same as the previous one that we did in the previous videos, okay, using the line by line method, okay. Here we use the function, there we used line by line, and in my view, line by line is a better method. The thing is, in the line by line, that you will relate each next line with the previous line, so you are going in a flow, okay. In this function particularly, you have to break the flow and recall some things from the very beginning, just like we recalled this RW Gaussian from the first line, okay, into another variable, which is Gaussian random walk, okay. You don't have to do that in the line by line. You get into a flow. Now that we have plotted it, now I want to replicate it, okay. But to show the replication, you need a variable, okay. So for that, you need to have another variable, okay. So for example, I want to have a variable as the GU replication, okay, and I assign it a value of the replicate function, okay. So it shows me n, how many replication, 1000 replications, comma, now I need to give the what I want to replicate actually. So I want to replicate the Gaussian random walk, okay, which already I have in my memory, okay. So I want to replicate this 500 steps, okay, 1000 times, okay. So now it should give me the replication. Now to see the dimensions of it, I want to see what are the dimensions of this replication, okay. So I want to have this Control C, and I need to put it into this, okay. And if I run it, okay, I need to run it with Control Z. I need to run it along with the first line, because GU replication is defined over here. Okay, so if I run it, it says that it has 500 X values and 1000 in Y. So 500 steps into 1000 replications. Okay, so total number of elements are 500,000. Okay, so if I want to recall the 499th element of each walk, okay, each replication, sorry, if I want to recall the 499th step, of each replication, okay, so I will have to put 499 in the X, and I need to ignore the Y because I am interested only in the X values. Okay, I already explained it on the paper. Okay, let me explain it again for you. Okay, it is like this. Okay, this X-axis represents the number of steps, okay, from 1 step to 500 steps. Okay, and this Y represents the replications, okay, from first replication to 1000 replication. Now I want this 499 step in each replication, so I need these number of values. Okay, so if I define the X only, so it will give me all these values. Okay, so for that, to recall anything in the matrix, what we say, we use the square bracket. Okay, so we will also use the square bracket over here. Okay, so we need another variable which is Y499. Okay, for example, it is a 499th element. Okay, so we assign it the value of the GU. Sorry, I already have in the, okay, and square bracket, and we use 499 comma. Okay, now in the next line, if I say Y499 or list 499, okay, let me see if list work over here. Okay, let's see if this works. Okay, but for that I need to have all these run. Okay, it is working. Okay, so it is listing me all of the 499 steps in each replication. Okay, this is the first replication. So in the first replication, the 499 step is on the 16.7 feet. Okay, for example, one step is a feet. Okay, steps are in feet. Okay, so it will go all along up to 1000. This is the 1000th replication. Okay, so it will list all the 499 steps. Okay, now if I want to have the mean of this Y499, okay, so mean of Y499, okay, so if I run it, so it is giving me the mean of 16.74. Similarly, I can have the standard deviation. Okay, standard deviation of Y499. So if I execute this, it will give me standard deviation of 0. Okay, now one other thing is the histogram of it. Okay, so I will use the hist function. Okay, now I want to make the histogram of the y499, okay, so it will be like same like we did in the previous one. Okay, we want to make the histogram of the y499. Okay, and here we have the probability is equal to true. Okay, and the main, okay, the name of the histogram, okay, it should be like for example histogram 499. Okay, for example I name it like this. Okay, now the X level, okay, the X level, it should be equal to, okay, the X level name. Okay, just like we have like a step over here, so the X level should be named as what should we name it? Position 499th position. Okay, now our histogram line is complete, but after this we need to write another line. Okay, and in this we need to define the color of the histogram line, okay, the width of the what we say histogram, and also all the lines. Okay, so we need to use the lines function, okay, for any graphics. Okay, so lines, first it's want to define y, we need to define y499. Okay, this is the object that we want to make the graphics of. Okay, then it wants us to define the color of it. Okay, so color is equal to, and I want to say red. Okay, so the line will be in red color. Okay, and the line width LWD, it should be equal to, for example 2 mm or whatever the measurement is. Okay, okay, it should be the density. Okay, density of the y499. Okay, so now if I execute these lines, okay, run it, it should give us a proper histogram. Okay, I have spelling mistake over here. Instead of density I have written the density. So now if I run it, it should give me a proper line. Okay, if I increase it, the size of it, okay, sorry, okay, if I make it full size, okay, so it will be like a proper bell-shaped curve. Okay, which shows that it perfectly defines the normal distribution. Okay, it follows the normal distribution with the mean of, here the mean of the 499 step is, we just found it over here somewhere, 16.74, and the standard deviation is 0. Okay, so that is how you can do it the other way. Thank you. I will now move to the next problem. Okay.